Okay, so let's look at the next Python interview question. So this is like a important question and it is being asked like almost all the interviews. So the question is, what is multiprocessing? What is multithreading? What is asynchronous and synchronous? So generally people get confused between all these terms. And even though people going to know like, okay, what these terms are, because by looking at the name of the terms, maybe they can explain. But if the interview said, okay, write some example, write some Python code explaining all these things like multi-synchronous, asynchronous, multiprocessing, and multi-threading, then it could be chances we may or may not get stuck in one of the code. Okay, so in this video we will see what is the actual difference. So let's look at the first, that is the synchronous programming. Right, so what is the synchronous programming? So synchronous programming is where it's the normal code. Like whenever you are going to write the normal Python code without any using any extra libraries like multi-threading, multiprocessing, or async IO or AIS, a normal Python programming code, like generally it is called as a synchronous. As an example, so what is synchronous? Synchronous is where each line of code is executed one after another. Right, so that is called as synchronous. So it is that is one task is going to perform at one time, and then the other task, then the other task, then the other task. Once the previous task is going to finish, only then the next task is going to be executed. So that is the synchronous, where each line of code is executed one after another. So as an example, so if you go to the Google and search for the fake REST API, right? So we got first link, that is the JSON placeholder. If you click on it, and if you scroll down, so this is the fake REST API. So we can hit this. So if you click on the post, so we are getting the post number 1, and if you click on the post 2, we are getting the post 2. So in this video we are going to go through the coding as well for the synchronous, and we are going to use this API. This is the fake API, so we don't need to write any REST API. We are going to use the existing fake REST APIs. Okay, so what is synchronous? So as I told you, where each line of code is going to execute one after the another. So what is the benefit and what are the disadvantages? And should I use this or not? Right? And when we are going to use the synchronous, when we are going to use the multi-threading, when we are going to the multi-processing, when we have to use the asynchronous. So we are going to see each and everything. Right? So synchronous means where each line of code is executing one after another. So as an example, if I give you one code, or some problem statement as an example, I told you, can you run get API, just a normal get API, because I'm hitting, right? So I'm hitting the get API. So can you run get API for 1 to 50 post? All right. So we have the 50 post, or maybe 500. Right. So it doesn't have the 500. I think it has the 100 posts they have provided. All right. So can you run? Can you run? So we can see how many posts they have provided. So they said something, yeah, 100 total 100 post. So if I told you, okay, can you run can you run the get request on the post, but for all the post, 1 to 50 post, or 1 to 100 post, what is the normal way? What is the normal way to write the code? What we are going to do? We are going to import the a request library, and we are going to run the request.get one by one, one by one. So first we are going to execute the request on this, on this URL, then the request.get on this URL, then the request.get on this URL. So one by one we are going to do that. That is called as a synchronous. So let's write the code. So I already read the code. I'm going to explain that. Right. So, and we are going to calculate the time as well in all these synchronous multiprocessing, and then we are going to calculate, okay, which one is the faster. Okay, so because we need to calculate the time, so I imported the time library, which is fine. So before starting the code, I'm saying, okay, start time is equal to time, which is perfectly fine. Now I need to hit the request on which URL? On this URL. Right, so I use this URL. And how many number of requests I need to hit? 50. Not the number of requests, but the different 50 URL. Okay, So what I'm going to do, I am going to use this request library. We are going to import, and we are going to hit request.get and the URL, and the URL should be /1/2/3, right? So we will run in a loop. So for I in range from 1 to 50, 50 plus 1 because the loop is going to run 50, and like one by one we are running the loop, and we are going to call the fetch post function, and we are passing the integer, and we are converting into the string because this is a string, so we need to attach. So the whole URL will become /1/2/3, and then we will print some message. Okay, I am hitting the first request, I'm hitting the second request, I'm hitting the third request. Then I'm hit the request, and I'm going to return the response, even though we are not printing any response, which is perfectly fine, right? So once all the requests are going to complete, we are going to calculate the end time. Okay, what is the time now? Now we are going to calculate the execution time, right? So let's execute this code. So Python synchronous. So if I hit this, you could see the request is going one by one. So I am running from first, or like where is the loop? Okay. So first it will go to the post/1, then it will go when the post/1 is going to be completed, then only post/2 is going to be hit. So if you click on it, so if you see hitting get request for one post, second post, third post, fourth, fifth, sixth. So all the numbers are in the sequence. All the number are in the sequence, and we have hit 50 posts, 50 requests on the different URLs, and the total execution time is approximately 6 seconds. So let's open the notepad, or not in the notepad. We can write, we can copy this. So copy this, and here we are going to write this. So we know synchronous execution time is taking. So if you see this code, I am, so let me minimize this. I am hitting the request one by one. No any fancy library I am using. So this is the synchronous code. But what is the disadvantage? What is the disadvantage of this code? So the disadvantage of this code is, let's go first. So the thread is started. All right. So whenever any request is hitting, so when is it is hitting the first post, when it is going to the post/1. So the request is going outside my computer. During that time, whether it is a millisecond time, whether it is a microsecond time, doesn't matter. But during that time, my CPU is in the idle state. All right. So during that time, my CPU is sitting idle because we are hitting the. So let me open the whiteboard. 1 minute. So let me open. Okay, checking some time. 1 second. Yeah. So we like this is some server. This is some server where from our we are getting. This is my computer. This is my computer where I'm running a program. So I am hitting the request from here, and the request is coming back, right? Request is, but when the first request is triggered, when the first request is triggered, so it took some time to go, and it took some time to come. During that time, my CPU is doing nothing, right? So my CPU is in the idle state. My CPU is not doing anything. So this is my CPU, or you can say this is my computer, and this is like the REST API server. REST API server. All right. So this is my REST API server. So when the request goes, so right, and then the request comes during that time, my CPU is being idle. So why can't I hit my second request? Because all the requests are not dependent upon each other. Because if I hit the first request, and why my CPU is idle, why can't my CPU like hit the second request? Why can't CPU my send the third request? All right, so it can send the third request during that time, right? But it is not sending because this is the synchronous code. All right, so because this is the synchronous code, right? Because if you even see, it is hitting one by one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and till 50. So there is a sequence. 50 is not coming before 38. All right, so there is a sequence. So this is the synchronous code. All right, so now we understand what is the synchronous. Now you can question. Now you can answer, okay, if we have to speed up. If we have to speed up, what we can do is we can use the multi-threading, which is perfectly fine. That should be our next approach. So if we have the synchronous code, so don't think about from the Python perspective only. I am taking about the normal term. But don't say like if this is not input output code, if this is CPU bound code, then the multi-threading is not going to be work because of the GIL concept, which is perfectly okay. That's why I took the example for the input output request. Right. So because the input output request is like a good example as per me for the asynchronous and multi-threading and synchronous, not for the multiprocessing, but still we will cover the same example so that we should know how the same code is going to be modified. Right. So rather than taking different example and confusing, we will take a same code and we're going to modify. So now we are hitting one request. So one thread is going right during that time. So basically my code is running using the single thread, right? It's using the single Python thread. So one thread come, CPU is in the idle state. It come, it when it gets the response, okay, then that thread going to finish. Then the next thread is going to be started, right? So it is like waiting so much time. So you can okay ask, okay, here it is one thread. Okay, what I can do is to speed up the process. I can use the multi-thread, which is perfectly fine. It should be our next. It should be our the next approach. So what we are going to do is, so this is our server, REST API server, all right, and this is our CPU, all right. So where the process is running, small processes are running, right? So this process, this node process, this code started, and this code is hitting one thread, right? Now you can say, okay, that's why it is taking so much time. So what we can do is, instead of one thread, we can execute multiple threads. So T1, T2, T3, T4, but it should be the part of the same process. T5, any number of threads, it's up to you. So you can hit multiple thread, right? So T1 is going to hit the post/1 URL. T2 is going to hit the post/2 URL. T3 is going to hit the post/3 URL. T4 is going to hit the post/4 URL. So every thread is like hitting at a same time or whenever basically it's hitting as soon as they get some CPU, they are going to hit. So we have the four core. So at least four thread at least going to be hit at the same time, right? So that is the multi-threading. So let's try that multi-threading. So go to the multi-threading. So to it's the same code, same library we are using. So we are using multi-threading, same function request dot get, same function, same everything. I have not changed anything. Same function, same time module, same everything. But now instead of directly calling, so here we have to call 50 times because the 50 different URL. So instead of directly calling one by one, we have to create the threads. We have to create the threads. So we will take some list, right? So we are creating a thread. So threading dot thread. So what that thread is going to do, that thread is going to hit this URL. Okay, which argument it is taking? So it is taking one argument. So I am passing one argument. I okay, which is fine. So one thread is being created. I am appending all the threads in a list. So I am appending all the threads in it. So why we are appending unnecessary into the list? Because we need here. We are going to tell you, I'm going to tell you like why we are appending, which is fine. So I created one thread, I'm going to start. So as soon as my thread gets started, as soon as my thread gets started, it is not going to wait for the to complete. My second loop is going to be started. All right. Maybe T1 is started. All right. T1 is not yet completed. T2 is going to be started. If then T1 get completed, T3 is going to be started. All right. So the next thread is not going to wait for the previous thread. All right. So that is the thread. All right. So let's try this. So, okay. I am going to explain this later. So what this like highlighted part, but we are doing the join. So let's run that. So it took 6.2. So let's take how much multi-threading took. So if you hit multi-threading, so now let's see. It took 3.7 second. So far less than the synchronous our code. far less than approximately half. Okay, which is fine. Now see this if you see this request number 1 hit, then request number 2 hit, then request number 13 hit, then request number 17 hit, then request number 12 hit. So it is not in the synchronous because the threads are getting created as soon as they get the some CPU, they are hitting. Whoever is getting the CPU, they are hitting. Whoever is getting the CPU, they are hitting. Right. So there is no sequence. There is no sequence. Who is getting the CPU, and they are not waiting for each other. They are not waiting for each other. Right. So all are like hitting like a jumble order. Right. Okay. Now why we are like appending into a list because we will end our code because these are the thread now. So if we don't write this code, our program is going to be ended because we are not waiting for the threads to be completed. So we want our code should finished when all the threads going to be finished. So that's why from threads, we are join all the threads into one process. You can say when the whole process is going to be finished, then we say our code is going to finish. So it is going to be wait. Okay, when like okay, T1 completed, T2 completed. So when all the threads get completed, they get joined. You can like consider in such a way. Okay. So now we understand the multi-threading as well. So multi-threading is okay, multi-threading is creating and managing thread. All right. So what is the advantage and what is the disadvantage? So advantage is definitely you could see the advantage because the time is less and we created so many threads. All right. But some people don't like multi-threading. Why? Because we have to create unnecessary lot of threads. We have to create unnecessary lot of threads. Even though time is taking less, it is increasing our execution time. All right, so it decreases our execution time. But like the problem is like creating and managing thread because we are first creating the thread, then we are storing into a list, then we are making sure they are get completed, we are joining it. So it is a resource intensive and we have to manage so many threads. All right. Okay, threading is mainly useful when we have to run the parallel. Okay, but like what the main problem? Because T1 is executed here, T1 because it is under the same process. T1 is executed, T2 executed, T3 executed, T4 executed. They all are using the same memory space. They all are using the same memory space. Like this highlighted memory space. Same memory space, same data. So there are chances that data might be corrupted because T1 is also using the same memory space, T2 also using the same memory space, T3 also using the same memory space. So there are chances like the data get corrupted. So generally, when you see the multi-threading code, some people are putting the lock when there are some writing. All right. So if the thread is writing in somewhere, then they are maybe in the database. Then they're putting the lock. Okay, mutex lock, some kind of thing. If you heard the terminology, right? So now we understand the multi-threading. Okay. Now let's look at the multiprocessing. So now we can say, okay, now we are saying, okay, even though we are creating 4 threads, all the threads is going to be run depends upon the how many CPUs we have available, how many cores. Okay, so at a time you can say the four like threads are going to be executed. So okay, when we say okay, creating the threads are like a resource intensive, then why can't we use the multiprocessing? You are fine. We have the four cores. So we have the 4 cores. So let's create here. So let's suppose we have the 4 cores, right? So this is the C1. We have the 4 core. Okay, 4 core CPU, 8 core CPU. It's up to us. So let's suppose we have the 4 core. So can't we execute like why can't we create the different process? So the P1 is going to be executed, P2 is going to be executed, P3 is going to be executed, and then P4. All right, so 1, 2, 3, 4 process is going to be executed. Yes. So for that we have the multi-processing library. So let's go to the code. So we have the multi-processing library, same code, same function, everything. Just we are using the multi-processing library. So for I in range, number of requests. Now we have to create the process. Earlier we created threads. Now we have to create the process. So multi-processing dot process. What that process is going to do? is going to hit that URL. What argument we have to pass? We have to pass that argument. Then we are like appending all the process. Then we have when we are going to like complete our code, when all the process is going to be completed. That is fine. All right. So this is our you can say uh, multiprocessing, like multiprocessing, right? So let's try to run this code. How much time it is going to take? So Python multiprocessing. Oh yeah. So different process get started, and it took 6.7 seconds, approximately same as the synchronous. Approximately, so no time difference. Only the difference is like it is like because first the process is going to be created, then the process is going to be like executed. All right. So, but the different order. So there is no synchronous order. Like all right. So there is no synchronous order. Okay. Now you can question. Now you can question why there is no time difference. Why there is no time difference? Like why the time is same as the synchronous? Why the time is not same as the why the multiprocessing time is not less than the synchronous? The reason is what is multiprocessing? Multiprocessing is run on the CPU, right? But the code which we write here is the input output code. So if I write the CPU bound code, na CPU bound code means like I said, okay, there is a long list. You have to calculate the square of all the number and then submit, or cube of all the number, or just sum all the numbers. So that computation, we are doing the plus, minus, addition, subtraction. These computation is done by the CPU. So if I write the code, the CPU bound, then you definitely going to see the like decrease in the time. So now we understand if there is a input output task. Input output means we are like doing some input output operation. So we are doing some input output operation, right? Then there is no need to use the multiprocessing. So if you don't want to optimize your code using multi-threading or asynchronous, so simply write the synchronous code. Don't need to write the multiprocessing because the time is going to be write the same as per me. If I am incorrect, you can like correct me as well, right? So but if it is a CPU bound task, if it is a CPU bound task, then definitely multiprocessing is going to be helpful. Right, so we already see like in within our code. In our code, it is not going to help. Maybe in some other code, a little modification, maybe multiprocessing take 5 seconds. But you are not going to see a very huge difference of 50% in the input output. Like it is six multi like so. This is the multi-threading. So how it took here? Why? I think in that, yeah. So it is the multi-threading. Okay. So 1 minute. Let me run the multi-threading again. So multiprocessing, multiprocessing. Okay, so I hit the multiprocessing code by mistake. Let me check. Multi-threading. So multi-threading took 4 seconds, and let me. Yeah, definitely is going to be take less than the synchronous. And let me hit multiprocessing. So it's taking time. Yeah, same time, 6 seconds. Okay, so now we are so multiprocessing is generally not going to be like a saver for the if you are like code is like input output based, then multiprocessing is not going to be very much helpful. You can still use if you want to use, but the multi-threading definitely is going to be helpful. All right, or otherwise just normal write the synchronous code if you don't want to optimize. Okay, now the question come from where this concept is come. Asynchronous, this is a new concept, right? Asynchronous. All right. And within the Python, we maybe hopefully you heard the keyword async IO or AIS HTTP. So async IO means asynchronous. Right, AIS HTTP asynchronous only. So the asynchronous programming is a very like wider term. Async IO and AIS HTTP is the library provided by the Python to implement the asynchronous programming. Right. So async IO is nothing. Async IO is just a library. Right. If someone asks what is async IO, async IO is nothing. It is just a library. Right. A normal package, simple as time package, request package. It is just a library. But what is the use? It is helpful to write the asynchronous code. Asynchronous code. Now you can question what is asynchronous code. Okay, let's come to the asynchronous. Right. So asynchronous. So now you can ask like when we already achieve our less time using threads, right? Then why we have to use the asynchronous and what is this asynchronous? Okay. So if you see here in this we create so many threads and we are unnecessarily creating a burden of managing the threads. Right. So what asynchronous did is, so there is only one code. There is only one code, right? So that is the asynchronous code. But there is only one thread you can consider. So the if you see the code, it looks like a synchronous code. Right. So if you look at the code, it looks like a synchronous code, but at the back end, it is behave like a asynchronous. Asynchronous means like it is not waiting for the thread to be get completed. Right. So what it basically did is, so basically we are hitting the post/1 URL, right? So post/1 URL, go to this server. So now we already hit the post/1 URL, right? So what it will do is it is just it is not going to like hold the further task same as the threads, because when the T1 thread is going to be executed, right? So T if there is a CPU core available, then T2 is also going to be executed. In case of multi-threading, T2 is not waiting for the T1 to get completed, right? So similarly, in this case, if the thread is going to be executed, the rest code is not going to be wait for that thread going to be completed. So once that going to be completed, the code automatically go here. The code automatically go here. Okay, it's going to complete it. Then I'm going to execute the other part. All right. So in this, we like why we have to use the asynchronous instead of the multi-threading, because there in we are like we don't need to create unnecessary threads, because I say at the we by looking at the code you could see it is a synchronous code, right? It looks like a synchronous code, but it behave like a synchronous. Basically it is working in a non-blocking fashion. When you are hitting one request and your CPU is idle, so it is not making your CPU idle. It is like process the further request, and then the earlier is going to be completed, then it is going to become there. Right. So it is in the form of a non-blocking. So let's look at it. It is a non-blocking manner. It runs the main thread, but it is not going to the other task for input output operation. Like it allow program to do other tasks while waiting for the slow operation to complete. Right. It is useful when dealing with the input output task, which is fine. So it acts asynchronously, but it looks like synchronously. So if you look the code, it looks like synchronously, but it act asynchronously. Okay. Now let's look at the example. Okay. So where is asynchronous code? So here is our, so this is also the same code, right? So same number of requests, same URL, same function, same number of loop we are hitting, same number of loop we are hitting, same calculating the time, little thing extra. Now I'm going to tell what are the things. So, so we are writing in the Python, which is fine. To implement the asynchronous code, we have to use the async keyword to make the asynchronous function. Alright. So whatever is the function which we want to run asynchronously, because this function is going to be hit, and we want if some our my thread is going to hit this function, the next task is not going to wait to complete this function. Right. So next task is not going to be complete. So first I need to create the async. I just have to write async. That's it. All right. I have to write just async as a keyword instead of function. So earlier, if you look at this code, it is a def. Now I just added async. That's it. Okay. Now the other thing. So if you look at this code, so just forget about this, what we have written, just forget about this. So even if you look at this, so this is same, this is also same. We are creating a URL, right? And we have to hit the get request, which is also same. Now we will see. Okay, we are running the loop for all the 50. We are calling the function fetch post function, which is fine. We are calling the function, but here if you see, we are calling the function. We are calling the function. In case of thread or multiprocess, here we are not calling the function. So there is no bracket here. There is no bracket here. We are not calling the function. We just created the thread and then we start the thread. Even in the multiprocessing, we are not creating a function. We just creating a process and then we start the process. But in case of asynchronous, we are calling the function. So I is equal to 1, first function called. I is equal to second function called, same as synchronous. So here I is equal to 1, you first URL going to hit, I is equal to second URL going to hit, I is equal to 3, third URL going to hit. Similarly, asynchronous, I is equal to 1, first URL is going to hit, I is equal to second URL is going to hit. Right? So by looking at the code, it looks synchronously, but it acts asynchronously. And to make it asynchronously, we have to add a couple of things. What are those couple of things? Let looks. Okay. Now, so what we have to do is, what is our main logic? So what I want is, whenever I hit the request, whenever I hit the request, it should not block my further code. That is the non-blocking manner. It should not block my further code. Okay. And I want, when this request going to be completed, I sh I should like get the, I should collect the response as well. I should collect the response. So when this get completed, I should come again and I should collect the response. So when I get hitted, so it took some time to get the response. So meanwhile, my further going to be executed. So when this get completed, I go here, I should go here and I should collect the response. Okay. I should collect the response. Okay. So here, so to do the input output request, to do the input output asynchronous request, we have the AIO HTTP library. So we have the AIO HTTP library. So if you go to the Google, write AIO HTTP library, even if you remove the gigs for gigs, just hit enter and not the PyPy project. So open the official documentation. Okay. So if you see, this is the asynchronous HTTP client server for async and the Python, which is fine. And you have to install this. So this is not a by default package. You have to do the pip install like AIO HTTP. Okay. So pip install AIO HTTP. Okay. Now, how to write the code? So you don't need to read. You don't need to learn this logic or all these things. Just whenever you forget, just go to Google, open the docs, AIO HTTP, and that's it. Just copy paste and run it. So how they are running it? They are creating a session. Why we have to create a session? We are going to, so they are creating some session, and from that session they are hitting the request AIO. So instead of request.get, they are actually doing AIO right? But they are creating a session. So they create one session, and from that session they are going to hit the request, and that request is also asynchronous. So I just copy the code from here and I just pasted it. So we created one AIO HTTP session, and from that session, so these are the normal thing, and from that session we are hit the request. So this is the get request. From that session we are hit the request. So basically we are hitting the request from the AIO HTTP, and that is the asynchronous. Okay, so we hit the request, but we need to wait. We need to wait for that. Alright, not we well, like, we don't need to wait. We will like execute the further action, because this is a non-blocking code. But we have to put some keyword. Okay, I hit this request. My thread should come here when that request should be completed. So I have to use the keyword await. I am awaiting. I am awaiting for the response to go to collect. And whatever the task we are going to hit, because this is the first task. All right, so I go for, again go to the whiteboard. So as I said, this is the, it is not going to block the further task. So my first task going to hit, right? So then the second task is going to hit. Maybe then first task is going to complete, my thread is going to come back, then the third task is going to hit, then the fourth task is going to hit. So what I am going to do is, I am not creating threads. I am just I am just what what all the request I have sent, what all the request I have sent. I am just like in a list. I am in a list. I am just noting down. I am just noting down. Okay, I hit this request. I hit this request. I hit this request. That request already hit. That request already. I am just noting down. Why I'm noting down? What is the need of noting down? Because as I told you, because we are hitting this request and we are proceeding further. But when this request going to be completed, we have to come back. We have to come back to collect the response. So that's why I am first hitting. Okay, I have hit this request. 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 I am collecting all the requests. So once all the 50 requests going to be completed, so this list is going to be created. So once this list is going to be created, I am gathering all the responses. I am waiting for all the responses to gather. So async IO dot gather and start task means just like expanding it. Right. So like I am waiting. I am gathering all the responses. I am gathering all the responses now. So this function. So earlier, even if you see this code, so I did not created any function. So for the for loop, I did not created any function, right? But in this code, I created asynchronous function. I created asynchronous function. So we have to create the wherever we are calling this await keyword, na, because we have to gather the response. So to gather and we have to wait to gather all the responses, right? We have to keep waiting here, all right? But basically, particular thread, it's not going to like stop my further execution. It is waiting. So if I use await keyword, I need to use the async keyword, and async keyword I have to use only with the functions. So that's why we create a function and we use the async keyword here. Okay, fine. Now, so we have to run this loop until my all the task is going to be completed. So run this function until all my get completed. So let's execute this code. So Python asynchronously and hit enter. Say hit, and it executed in 0.77 second. So it executed in, so let's go to code. And it executed in all the requests executed in 0.7 seconds. So instead of the multi-threading, you should always use asynchronous, because in the multi-threading, na, what you are doing, you are creating threads. And even though you are creating threads, let's suppose you created 50 threads, but at a time, how many threads are going to be executed? Only four, because you have the four CPU, four core, maybe the eight core on the eight thread is going, not the 50 thread is going to be executed, right? So that's why their time is definitely going to be less than the synchronous, but more than the asynchronous, right? And along with there is an overhead because we are creating the thread. But in asynchronous, we are not creating the threads. It is a synchronous fashion. We are hitting, but we are not waiting. We are hitting, we are not waiting to collect the response. Right? We are hitting the request, hitting the request, hitting the request, hitting the request. That's it. So single thread is hitting. But in this case, four thread. Let's suppose I have the four core CPU. Four thread going to be hit at a time, but fifth thread only will be hit when any one of the thread going to be completed. Right? So five thread can't be hit at a single time for the four core CPU. But here, not even five, 10 requests going to be completed. Let's suppose one request did not even get completed, but meanwhile, my all the 50 requests get hit. It get hit. It's still waiting for the response, but it get hit. That's why it is waiting. That's why it took like very less time. So how to what is asynchronous, we already told you. So where is the main benefit? The main benefit is when we have to use the input output task. So basically the interviewer asks what is multiprocessing, what is multi-threading, what is asynchronous, what is synchronous, what is the difference. Even if they said okay, write the code, you can give this example, which is perfectly fine. And synchronous, normal code. Multi-threading, when it is useful, when we have the input output task. Asynchronous, when it is useful, when we have the input output task. Multiprocessing, when it is useful, when it is a CPU bound task, not the input output bound task. Okay, so that's it. So if you want, I can share this code on my GitHub repo as well. Otherwise you can like note down by pausing from the video. So like it's very simple. Synchronous normal request dot get, we know. Multi-threading, we know there is a threading library, we can create a thread, and we know we have to start the thread, we have to join the thread. Similarly, multiprocessing, we need to create a process, we have to start the process, we have to join the process. Even though you can like use the advanced multiprocessing pool, we have to create the multiprocess pool, right? But to make it simple, I'm using this. And for the synchronous, we know it is a synchronous fashion. The code is synchronous. So we know if the code is synchronous, we have to run a loop and we have to call the function. We have to run loop. It we have to call the function, but we have to make the code asynchronous. We should not wait for the thread to get completed. Right? To make it that, we have to use the async keyword and we have to import the async IO library. And that async IO library we are use here, get all event loop. So this event going to be triggered. So here we are using the async IO. So we have to wait until all the actions go to be completed, right? And we have to use the async. And for the HTTP request, we have to use the AI HTTP, which we're going to install. And to how to use that AI HTTP, just Google it, and we can paste the code. So don't need to remember the code, which is perfectly fine. We have to just know we have to use the async keyword. If we are using the async, we have to use the await keyword. Okay, we hit the request, then don't collect the response, just wait. Don't collect the response, just wait. Because if you are collecting the response, then it is not asynchronous. Just write the keyword await. All right. And then once all the, and we have to note down, okay, but all the requests we are sending, but all the requests we are sending, we have to note down somewhere. And then we are gathering all the responses together. And when we are like complete waiting. Okay, so that's it. That's the end of the video. Thank you.